this is Lori and welcome to my series on the Pico W. This is part 10 of the Exploring LED Displays series. In this episode, we're going to be working again with the 8x8 LED matrix and controlling it using two shift registers. All the components that we're using in this episode we've used before. If you're interested in understanding the LED matrix better or shift registers better, it would make sense to go back and view some of the previous episodes where those components are discussed. So these are just some slides from those previous episodes just to remind us of what we're working with. Here's our 8x8 LED matrix with the 6 pins and labeled with what row or column they control. And just so you know, when I'm doing my programming, I happen to have a common anode. But if you have a common cathode, then you would reverse the logic to use that. As before, we're going to use the 74HC595 shift register, and we'll daisy chain these together to control the rows and the columns of our 8x8 LED matrix. And we'll go ahead and send in the zeros and ones indicating which rows and columns we want to turn on. We'll fill up this shift register, and then as we continue to push in bits, it'll move out and connect into the next shift register. So we'll connect this QH pin to the serial input pin of the second shift register, kind of like shown here. And then we'll connect together all the control pins of the shift register, the latch pin, the shift register clock, and the clear pin, and then these will connect back to our Pico. So just like we did with the bar graph in the last episode, part 9, we'll do the same thing with our two shift registers to control the rows and the columns. So one shift register will be devoted to the rows, and another will be devoted to the columns. Here's the circuit we'll use. It's a mess. Even trying to draw it. I tried a couple different ways to draw it so it was as clear as possible, and quite frankly I think it's clear as mud, but hopefully you can figure it out if you pause this video and take a long look at it, but I'll try to go over the general areas. So what makes it so messy, of course, is that the pins on our LED matrix are jumbled up in terms of where the column pins are and the row pins are. They're not all one on one side and one on the other. So I used green wires in this diagram for the rows, and I used blue for the columns. And then I went ahead and connected the columns pins through current limiting resistors, and that then got connected up to this first shift register that's sort of buried underneath all these blue lines coming into the first shift register. And then you can see the green lines are all kind of connecting into the second shift register. And then you can see that I have the control pins interconnected between the two shift registers. And then the first shift register goes back to the Pico for control. So this is the serial input pin on this side, and these are the two clock pins and the clear pin. And then you can see that QH prime pin for the first shift register is connected to the serial input pin for the second shift register. So this shift register is columns, and this shift register is the rows. So as I have it connected, row 1, it goes to the QA pin, row 2 goes to the QB pin, I should say, and ultimately row 8 will connect into QH. And then the columns is similar. Column 1 goes to QA, and column 2 goes to QB, and so forth. So that just is important to know, because as we push the bits into the shift register, we have to know which one is getting ultimately a 0 or a 1, which one is turned on, which one is turned off. So that's the way I decided to arrange it. It could be done in any arrangement that you wish that might make more sense to you, but this is how I decided to connect it up. No, I've talked about bitwise operators and powers of 2 in terms of binary numbers on previous episodes. So I just put this slide here again to remind everybody that we were going to use some of these bitwise operators. So if you're not familiar with them, they could be a little challenging to understand. So I just showed some examples of maybe a binary number that we wish to send into our columns or our rows. Columns probably because of the way I'm doing it for this episode. And then if we want to shift right by 1, then what we'll do is we'll drop off one of the last place in the binary number, and you can see what we would get. And then if you dropped off 2, you drop off the last 2 and 3. So we use this shift right to work our way through the binary numbers as we're inputting them into our shift register. This is an important operator we use. And the other one we use is the bitwise AND with the number 1. And what that'll do is give you the last digit in your binary number. So you can see here, we're using that binary number again. If I bitwise AND with 1, I get the 0. If I shift over and then bitwise AND again, well, I'll get the next one. And so these two things are important for the loop that we use to input our binary numbers into the shift register to decide which row or columns are going to be on or off. The other thing that I use is powers of 2 with the binary number. So just to remind you, 2 to the power of 0 would look like this in binary. 2 to the power of 1 would look like this. 2 to the power of 2 looks like this. And then 2 to the power of 7 would look like this. So we move the 1 through the 8 different positions that we might have as we start to work with these binary numbers and want to turn on very specific rows. In this example, this is how we could select a particular row that we want to work with as we send in this information to the shift register. All right, let's just take a quick look at the circuit in real life. So you can see the LED matrix I have here, and the blue wires are the columns, and the green wires are the rows. And you can see what a mess it is to try to create it so that I could actually see the LED matrix when we film. And up here you can see the network resistor or resistor array that I'm using. It's 470 ohm. So all the columns go through the resistor array and then come into the shift register for the columns, which is sort of buried under all this blue wires here. And then this one is the shift register for the rows. So the columns are first as we push down the bits. We're going to push in. It's the first register. So as we push bits in all at once, we're going to push down the row bits first, and then push the column bits in, because we'll be pushing in 16 bits. 8 bits for the rows and 8 bits for the columns, and the bits for the rows need to go first. And then you can see back here just barely the Pico. Let me see if I can bring that into view maybe and just slide back a little bit here so you can see the whole setup. It's hard to hook up with wires, and as I've said many times, these are very hard displays to set up, and that's why everybody uses these with driver chips that already have a module put on, so that control is so much easier. But it has been interesting, I think, over these past 10 episodes to try to use these simple LED displays on our own without any driver chip. Just to kind of understand how they work. And it's taught us a little bit about shift registers as well. Well, our first program will try something really simple, just kind of working with the rows one by one. And you can see what this program is doing. You can see it's kind of flipping back and forth, going down the rows, shifting for LEDs on and off in each of the columns, kind of row by row by row. So just a way to see if our LED matrix is working right, and that we can light absolutely every LED on there, and that we can manipulate the rows and columns. All right, so let's cancel out of that, and let's talk about the program that we need to do that. All right, so if you haven't followed any of these lessons before, a lot of this code we've written in other episodes of the Exploring LED Displays series, and a lot of that is setting up the shift register and functions to control it. So if this doesn't make any sense to you, you might want to go back and take a look at that. But here's our typical shift register control pin setup. We're going to set everything to off settings, and we have our functions to operate the shift register: a clear, tick the shift register clock, and flip the latch pin. And then this is the new function that we've written to control the LED matrix. So now we're going to be able to shift in 8 bits for our rows and then 8 bits for our columns. And we'll do the rows first because it's the second shift register that controls the rows. So we'll take our row number, and usually I put these in as binary numbers because to me it's just visual to see what is going to be on. That would be a 1, and what is going to be off, that would be a 0. Now, because of the way we have it wired up, I really only want to activate one row at a time because I only have current limiting resistors on the columns. So that means I really don't want to operate multiple rows at the same time, because then I'm splitting the current limiting resistor across multiple LEDs. So really want to operate this just one row at a time, and that's the way we're going to do it in the program. So typically I'll only be telling it which row I want to turn on. So we'll work through that, figure out which row should be turned on, and you can see here if it's a 0, then we're going to have that, we're going to send in a low signal, meaning that row should be off. Or if it's a 1, we'll send in a high signal so that row is turned on. Each time we're ticking the clock so that we're filling up the storage register. Then, so the rows went in first, and now we're going to put in the column bits as well, using the column value that we want. So which columns do we want to turn on and off? And we'll use the same kind of loop. But you'll notice here, because I'm using an anode display, when I want the column off, I'll set it to high, and when I want the column on, I'll set it to low. So this is where you would flip it for a cathode. And again, ticking the clock. So once we've sent in all 16 bits, then we'll flip the latch pin and see the output. So everything will get sent out to the output pins, and it'll turn on the various parts of the LED matrix that we asked for. All right, so we'll just clear everything out before we start our loop, and we're going to loop through the rows. And you can see here's where I'm using the powers of 2 to select the row I want to turn on. And then here's the column that I want turned on the first time, sleep just a little bit. Then for that same row, I'll turn kind of the opposite or the mirror of that on, sleep, and then come around and catch the next row. So that's how we made that pattern go down our LED display. Yeah, it's looking pretty good. So that's a pretty simple use, and I think it kind of gets us feeling like we understand how we want to operate it. But now we'll want to put whole graphics, or perhaps we'll want to put characters so that we can form messages, those sorts of things. So we'll want to kind of work with a whole 8x8 graphic at a time. And so we'll want to develop something that we can use to work through that. All right, so our next program will try to display graphics onto our 8x8 LED matrix. And we'll need to use persistence of vision because, as I said in the previous thing, we only want to activate one row at a time. So we're going to move super quickly through the rows so that persistence of vision gets brought into the picture, and it looks like everything is just all rows are displaying at the same time, but they're actually being quickly turned on and off. All right, so let's see how we do this. Same setup as before, all these familiar functions, and here's the one we wrote in the first program. to send in row and column values to our two shift registers. And now we'll need to have a function that will allow us to quickly loop through the rows, and we'll call that row column right function in here as we're looping through the rows very quickly so that we can send the picture that we want to put in. So this is very similar to the other functions I've written in the other episodes here. So we'll give it a graphic, a whole graphic, and you can see this is how I decided to code the graphic. I used binary numbers as a list. And so, for example, you can see that this is going to look like a music note. And we'll need to give it the two timings that we have to have for persistence of vision. How quickly are we going to work through the rows? So that's in microseconds. So this is 1,000 microseconds. You can use anywhere between 1,000 and 2,500, I think, will typically work. And you can fine tune that for your own setup. And then how long do you want to display the graphic itself? You know, how long is it going to sit there and loop through the rows, loop through the rows, loop through the rows? So I have that in microseconds. So we start our clock, and then we check to see should we keep looping so that till we exceed that display time that we wished for. And then here we are looping through our rows again using our row column right function, selecting the row that we want to activate, and then selecting the part of the graphic that we want for that row. And here's our persistence of vision timing. So as we move very quickly through this for loop, it's going to be going super fast. And we got 3 graphics in here. We have a music note, a tree, and a house. So you can see now that we have all these nice functions, this is pretty simple. We'll just display the graphic for the note, and we'll display it for a second. We'll display the tree for a second and the house for a second. And when we do a keyboard interrupt, we'll be able to close out the program. All right, so let's see this one go. Yeah, I'll just keep going around. So yeah, our persistence of vision works. And you probably noticed that you can see that they're a little dimmer because now we're quickly moving through the rows, so it's not as bright as the previous episode where we weren't using persistence of vision. So that's one of the downsides of it, is that we lose a little brightness. But that works pretty well. All right, and as we found when we worked with the 8x8 LED matrix before, usually what people often want to do with these displays is they want to scroll text or scroll messages across. So let's take our 3 graphics and let's figure out how to scroll them. All right, this slide came from the part 8 where we first started working with the 8x8 LED matrix. And in that one, we were actually scrolling some text across the screen. So imagine these are the 3 graphics that we wish to scroll. Well, it's pretty easy when we have something like this L here. We have that coded into our program. But then as I want to scroll it, what I really need to do is move this window. So the next graphic after the full L, I want to drop off one column, and I want to pick up the first column of the next graphic. And then the next graphic I want to show is the combination of the six last columns of the first graphic and the first 2 columns of the second. And you can see you'll use this sort of window to move across. So we'll need to put together a function to do that. And we did that in the first 8x8 LED matrix episode. And we'll need to do that here as well. And it's just a little bit different using the shift registers to do that. Well, for those who've been following the series, this program is going to feel very similar to the one we did in the first episode on the 8x8 LED matrix, where we connected all the pins of the matrix directly up to our Pico. So now it's just a matter of using shift registers to control the LED matrix rather than pins directly connected to the Pico. So we'll need to set up our shift register, and then here's our row column right function, and our display graphic function. And here's our graphics that we wish to scroll, and I threw in a blank. It makes it a little nicer. So the message I want to scroll across is a blank character, then the note, tree, house, and blank again. It just looks a little nicer with the blanks in there, I think. And now we need this windowing function. And again, this is pretty similar to the other one with just a few small tweaks to make it work with the way I have the graphics coded in this version and controlling the shift register. So we basically need to take the two graphics that are next to each other, and we need to get the combination of them that we want. And so the shift will tell us how many columns we need to shift over. So we'll not shift at all, or we'll shift 1 through 7 columns to shift from one character to the next. So to do that, we'll need to create a new graphic with the parts of each of the graphics that we need. And this F string here just takes those binary numbers and turns them into a string. And then I can pull off the zeros and ones I want from the first graphic, and then pull off the zeros and ones I want from the second graphic, depending on what shift I've asked for. So that seemed to work for me. I guess there's probably a lot of different ways to do that, but that was what I thought of first, was just using an F string to turn them into strings first. Then I'm going to combine them and then turn them back into numbers, binary numbers here. So you can see I have the end function, but with a 2 here to make it binary. And then that will create that new row. We'll append it into the graph. So we'll go through row by row, making the row that we need for this shift, and then we'll return the new graphic to the program. Might take a little time to think about. It doesn't take all that many rows of code to do. I was surprised. I mean, I have a lot of comments in here, actually. And I'm sure there's probably more efficient ways to do it than I did. But this seems to work. All right, so when we want to go through our message, we'll loop through the message, and then we'll shift the letters off the display, one column at a time. And so here's where we're working with 2 of the characters next to each other, shifting across. Then once we finish through that, we'll move to this character to here and pick up the next one, and then do the shift through of that pair, and keep going and going and going until we do a keyboard interrupt. All right, let's give this a go. Hopefully it'll work still. All right. Yeah, there we go. Yeah, so you could, instead of the graphics that I put in this time, you could put characters and send messages and scroll them across. And you can see here with the display graphic, you can choose how fast you want the scrolling to go. And as many of you might know, if you use a LED display with a driver chip and a nice library, you could scroll forwards and backwards, and so somebody's done a lot of programming to make that all possible. And as I've said before, that working with these displays without those driver chips has certainly made me appreciate how nice those libraries and modules are. Well, that's the final episode where we'll be using the LED displays without driver chips. The next coming episodes will be using LED displays with driver chips. As always, I want to thank you for watching.